Welcome back. I hope you are enjoying our lectures. In the previous lectures, we understood what is transactional processing and what is analytical processing. For analytical processing, we would need a data warehouse, and there comes Hive as an open source data warehouse. But if you really look at the data ecosystems, there are many systems which use RDBMS, like Oracle, we have MySQL, PostgreSQL. So it is very important to understand how Hive is different from RDBMS systems. Let us look at that as a part of this lecture. Hive can be compared to the RDBMS systems in different ways. Maybe in terms of data size, maybe in terms of the way the computations are done, maybe in terms of latency, in terms of operations, in terms of asset complaints, in terms of query language also. Let us see them one by one. At a high level, we know Hive has large data sets. RDBMS has small data sets. Hive does the parallel computations. RDBMS would go for serial computations. And we have high latency in Hive, we have low latency in RDBMS. Mostly we have read operations in Hive and we have read and write operations in RDBMS. Hive is not ACID compliant by default, but RDBMS need to be ACID compliant. We use HiveQL in Hive and we use SQL in RDBMS. We'll look at all these things in detail in the upcoming slides. As we already understood, Hive uses the large data sets, RDBMS uses the small data sets. In Hive, we potentially try to deal with gigabytes or petabytes of the data. On the other hand, in the RDBMS, we usually deal with megabytes or gigabytes of the data. We use Hive on the large data sets for calculating the trends. If you remember a story or example where Monica was trying to find the trends. Monica was trying to analyze the data of 4 to 5 years and see why the revenues were very low in a particular month. That is where we are using the data warehouse for a transactional processing. Hive is an open source data warehouse. That is the reason Hive works on the large data sets and it calculates the trends. On the other hand, in our RDBMS systems, we usually work on the small data sets for accessing and updating the individual records. Remember Vivek, where he was trying to update around 10 records to assign the shipments to a different courier company. In Hive, we do parallel computation. In RDBMS, we use serial computations. As we know, Hive is a part of the Hadoop ecosystem. Hive intrinsically does the parallel computation because it is a part of the Hadoop ecosystem. Hadoop ecosystem is a system for distributed storage and distributed processing. Since Hive is a part of the Hadoop ecosystem, it does distributed processing across the multiple machines. But RDBMS systems are mostly on the single computer with the backup. Hive does the parallel computations on structured, semi-structured, and unstructured data, which is partitioned across the multiple machines. On the other hand, RDBMS systems does the serial computations on the structured data in the tables on one machine. Why are we going for a parallel computations? We already understood because disk space is very cheap, storage is very economical these days. we can easily add more number of machines. Hadoop framework supports adding more machines horizontally. Because of that, we want to go for a parallel computation as a part of Hadoop ecosystem, and since Hive is a part of the Hadoop ecosystem, it does the parallel computation. On the other hand, if you really look at the RDBMS systems, they are installed in a server, expensive servers, which are mostly a single machine. High latency and low latency. What is latency, by the way? We have already discussed this as a part of our previous section, but at a high level, latency is nothing but delay. Delay in something. When you say high latency, what does it mean? More delay. When you say low latency, what does it mean? That means less delay. That means it is fast. We understood what is high latency and low latency. When we work with Hive, we cannot go and access the records or the data quickly. That is the reason in Hive it is mostly high latency. That means to access the records, to access the data, it takes more amount of time. That is because of couple of reasons. One is we already understood. One reason is the data what we are dealing with is already huge. The second thing is it is not even indexed. Indexing makes data access faster. That is the reason in the RDBMS systems, since the data is indexed, they can be accessed and updated fast. And the second thing here is amount of data what we are dealing is also less. One more important aspect which contributes to the high latency in case of Hive, we already understood Hive jobs or Hive queries invoke the MapReduce jobs under the hood. So whenever you want to fetch a row from a data which is there in the HDFS, it has to convert the HQL into MapReduce jobs. Then MapReduce jobs will go to HDFS and fetch the records. That also contributes to the delay in getting the data. On the other hand, since the data is indexed, there is no other job like MR jobs here. The queries will be answered in milliseconds or microseconds in case of RDBMS systems. Mostly, Hive is used for read operations. On the other hand, RDBMS is used for read and write operations. Because if you really see, Hive is not the owner of the data. Where does Hive store the data? Hive stores the data in HDFS, that is Hadoop distributed file system. As we already discussed, Hive stores the file in HDFS. Hive files can also be read and written by other technologies like Peak, Spark, and other tools or other components as a part of the Hadoop ecosystem. Because Hive stores the data in HDFS, Hive cannot enforce the database schema on these files. On the other hand, RDBMS system is the sole gatekeeper of the data. What does it mean? It controls the data. Nobody can touch the data without its permission. Because the data is stored in HDFS and Hive is just exposing the files in HDFS as tables to the user. That is why it is a schema on read. We are enforcing the schema while reading the data. To discuss further, what do we mean by schema on read? Number of columns, column types, constraints are specified at the time of the table creation. Just to understand the schema on read further, Whenever we are working with the Hive, number of columns, column types, constraints is not specified at the time of the table creation. What Hive does is Hive tries to impose the schema when the data is read. Whenever it is not succeeding, then it pads the data with the nulls. So if we define the schema while creation itself, we can take care of the null values and all those things. But if you don't enforce the schema while creating the table, then what happens is we cannot really manage the null values and all those things. That is the reason Hive imposes a schema when we are reading the data from HDFS and exposing that to a user. If it is not succeeding, then it will pad the values with nulls wherever there are no values. On the other hand, in case of RDBMS, it is schema on write. What does it mean? When I say schema on write, if you remember, if you have worked on any of the RDBMS systems, you got to create the schema first there. Then schema would have like keys, primary key, foreign key and all those things, and many constraints. After the schema is defined, after we specify, then only we can create a table, then only the data will get into the table. Otherwise, any data which is not conforming to this schema cannot be put into the table in a database. Hive is not ACID compliant by default. On the other hand, RDBMS systems are ACID compliant. What do you mean by ACID compliant? ACID compliant is very much prominent in RDBMS systems. ACID stands for atomicity, consistency, isolation, and durability. What are these? These are set of properties that ensures reliable processing of the database transactions. Remember, we discussed a person would go to an ATM and he withdraws money. As soon as he or she withdraws the money, there will be immediate message sent to his or her phone. That is in a way enforced by ACID compliance. Only data which satisfies these constraints would be allowed to store in a database. But on the other hand, Hive is not a ACID compliant because Hive stores the data in HDFS. Data can be dumped into the HDFS in any way. It doesn't matter whether it has a schema, it is not having a schema, it doesn't matter. Any data can be stored in HDFS. In the end, we'll understand how HiveQL differs from SQL. HiveQL, we know it supports schema on read. There are no constraints here. But here it is a schema on write keys, not null and unique, all are enforced. There is no R minimal index support in HiveQL. But on the other hand, SQL allows the indexing. Row level updates are not much supported here. Deletes are all treated as a special case. Row level operations are very much a daily routine in case of SQL. There are many built-in functions in HiveQL, but there are basic built-in functions in SQL. Here, mostly in case of Hive, very minimal support for joins, or rather there are joins, but not much used in Hive. On the other hand, there are so many wonderful joins which are there in SQL, and we use them left and right. There are restricted subqueries. There are so many subqueries in case of SQL. Wonderful. We understood how Hive is different from RDBMS. Thank you.